Thank you, Louise. Thank you, Ian. Luis, by the way, if he never used Spring before but I met him, he hid it pretty well, I have to say. So he's either a genius or he's really devious. So welcome, everybody, and thanks for coming. I know you had choices. You didn't have to come here. You could have gone somewhere else to have your pizza and free beer, I'm sure. But it's nice to see you all. You guys know you're on wheels, right? You could probably have some fun with that later. All right, so I'm Dave. How can I introduce myself? I work for Pivotal. It feels like I've sort of had the same job since about 2006. I think Spring has changed a bit in that time, and maybe I had something to do with that. I certainly have tried to push things along a little bit from time to time when I needed to, as Louise has noticed. And what else? I used to work in finance. It's a little bit of a dirty secret in my background. Before that, I was actually an academic. I used to be an astrophysicist. If anybody wants to ask me about that, they can probably go back to 2005 and ask me then, because I've forgotten it all. Actually, you have to go a bit further back than that, probably back to 1998. Anyway, yeah, now I live in London, so I came here for the day. Anybody who wants to, have a chat with me afterwards, please do. I'm only 463 kilometers away. If you wanted to see me again, you only have to ask. It's not very far. It's very easy for me to be here. I've got maybe 55 minutes now to tell you what's going on at the minute in Spring. And as Luis has pointed out already, today was a big day. Did anybody already see Spring 5 on the Twitter feed? If not, then dial up at Spring Central or at Spring on Twitter and see what's going on there. Because it was released today. So I'll give you a bit of the background and what's going on around that, because Spring 5 isn't the end of the story. There's quite a lot of big changes happening in Spring at the minute. I know we already did this a little bit, but how many of you actually use Spring? Quite a few, good. Who's never used Spring? That's probably an even better one. Okay, minority, all right. Hopefully you won't get too lost too quickly. I'm not actually, the technical bits I hope will just be demos, so you can probably follow what I'm doing because they should be easy. That's the idea at least anyway. But please ask if you have questions or if I'm not being clear about anything or if you want to change the direction. I'm sure that Ian and Luis have got microphones, so if you just raise your hand, we'll get you to ask a question and I can see if I can answer it. No trick questions. Okay, so what's happening in Spring in 2017? How does it maybe fit all together? So there's a spring.io link there. There's also a projectreactor.io, completely different website, but as you'll see, becoming somewhat connected to the whole Spring landscape. So we often do layer diagrams in technology, don't we? We like layers, we like our cakes. So this is a green and blue cake. I've never seen a green and blue cake before, but it has all of the essential sort of ingredients about what you might be consuming if you're consuming Spring these days. The essential message here is that there are actually, the biggest thing should be the third-party libraries. Like this big blue thing at the bottom is actually 99% of the code that you use. And then what Spring aims to do is to sit on top of it, and it becomes a sort of a consumer layer. It's what you pick up if you want to integrate with things. I think that's probably, I can see people nodding. I hope that's the people's experience. And so the way that we've organized it, we've got Spring, and that's a big umbrella for all the Spring projects, the Spring X, where X is framework, security, integration, AMQP, batch. Trying to think of, there's probably about 30 or 40 at least of those Spring projects. which sit on top of the third-party libraries and give you integration points and a common, this is the key thing, a common programming model across all of the third-party tools that you might want to use. And then, okay, so that's actually going back, I guess, traditionally that's what Spring was. Going back to the beginning, 2003, 2004, that's what Spring was. And it used to be one jar file, right, spring.jar. And then when it got to be like 120 jar files, it started to get a bit difficult for people. So Spring Boot was sort of the answer to that. It was kind of a funnel. It gets you a quick launch pad, a quick way to get started using the Spring technologies. And it's opinionated, and that was the key thing. That's the thing that Spring Boot has that Spring had less of, at least anyway, or has less of, because none of these things are going away, they coexist. Spring Boot is kind of opinionated about how to build Spring applications. And then a couple of years later, another thing I was involved in was Spring Cloud, which is kind of another layer on top. It builds on Spring Boot. It uses the Spring Boot philosophy about being opinionated and exposes new integrations primarily aimed at distributed systems. So that's why it's called cloud. It's not really anything to do with the cloud. It's more to do with distributed systems, but that sounded like a bit of a mouthful, so we called it Spring Cloud instead. Okay, so those are the basic pieces. If you break it down a little bit, it maybe looks a bit like this. So I've shown in the Spring layer there that there are other things inside there. Spring Data is one of the ones I forgot. So Spring Data is an enormous umbrella project, right, including support for JPA, relational databases, lots of NoSQL stuff, Redis, Cassandra, data stores, Elasticsearch, all of those things. And so I've sort of shown those being broken up in the Spring layer there. Spring Boot has shifted to the side a little bit because I wanted to make room for the thing that I've put in the middle there, which I've called Spring I/O platform. How many people have used the Spring I/O platform? Interestingly, not very many. The idea behind it's very, very thin. The idea behind Spring I/O platform is it's just dependency management. It makes it easy to know that you're using version X of Spring with version Y of one of the things it integrates with, and that they work together. So it's dependency management. And the reason it sits on top of Spring Boot is because Spring Boot already solves 90% of that problem, and then all we did with the platform is just add additional third-party libraries that are not included in Spring Boot. So that's the platform. And then Spring Cloud I've split up into some other bits. So there's a sort of Spring Cloud core, which is all of the Netflix and Zookeeper and distributed systems patterns. And then there's a special thing called Spring Cloud Data Flow, which has a separate release process. That's the reason I put it in a separate box. And that's to do with pipes and filters, basically, and a programming model and an application development model for pipes and filters, data streams. Okay, so here are the hard numbers. Often when people actually do give these presentations, they show you download trends and numbers and things like that as well. The numbers are a little bit hard to interpret, so I haven't bothered doing that. But Spring is growing, for sure. Spring usage is growing by any measure. It's just a little bit hard to quantify, I guess, how many people are using it. Millions is the answer. Anyway, as of today, September 2017, we have the following pieces have been released. Actually, I've slipped up and forgot to update this slide because today was the Spring 5 release day. So this is yesterday's picture. There's Reactor, Project Reactor, which I'll come to in a minute, which was at an aluminium release train. So we use these alphabetic release train identifiers. And so aluminium was the first one. Spring Framework was at 4.3.11. Security was at 4.2.3. Spring Data had a release train called Ingalls, so they've been through A, B, C, D, E, F, G, H, and they're up to Ingalls. K is the next one. And Spring Boot was at 1.5.7. Spring Cloud We have a release train based on London transport stops, so Dalston. Dalston has had a service release, so that's what those SRs are. So we start with a release, and then we go service release 1, service release 2, service release 3. And they sort alphabetically, so you can list all the releases in sort of lexicographically, and they line up. That's why we do it that way. Okay, so that's just the baseline. And then when Spring 5 comes, i.e. today actually, September 28th, 2017, Spring 5 was released, and what's changed in Spring 5? The punchline will be, hopefully for many people, if you don't care about it, you probably won't notice the difference. That's the way that we like to do Spring releases, right? You just change the jar files, and whatever you were doing before tends to work. Now with Spring 5, because we've gone from 4 to 5, it's a major version change. We have taken the opportunity to make some changes that maybe will break existing code. This is the almost once in a decade opportunity. Once every 5 years or so we do this. I wouldn't like to predict exactly where that's going to happen, but there will be places where existing code will break, and you probably have to either recompile or maybe just change a package name or something like that. We do try to make it as easy as possible. And there have been deprecations in Spring 4, which are now removed. So that's the sort of day-to-day easy stuff. The basic order of the day is the baselines. So up to Spring 4, we tried really hard to support multiple versions of the JDK. So we had, in Spring 4, we still supported Java 6, even though it's been dead for ages. I mean, there are still people who have the unfortunate experience of having to work with Java 6. Spring 4 was a Java 7 baseline, but we supported Java 8. So we actually had Java 6, 7, and 8, I think also 5, working in Spring 4. Spring 5 is an opportunity for us to throw that away and say, right, from now on you have to be at least with JDK 8. We are also supporting JDK 9, which also was released this week, you might have noticed. Anybody tried Java 9 yet? Nobody tried Java 9? A few people. Ah, good. Okay. Well, it does work with Spring. Some other things, so we usually raise the baseline of all the enterprise APIs as well, so Servlet 3.1 has some new features over Servlet 3, and we don't support Servlet 3.0 anymore in Spring 5. JMS 2, JPA 2.1, things like that. There have been some performance improvements. We care deeply about performance. We measure it. If you think that Spring is slow, you're probably wrong, because we measure it a lot. And it's probably not Spring that's slow. It's probably the fact that you have a big ball of stuff that you're shoving on top of Spring. Spring itself isn't likely to be adding a lot of overhead at this point in time, but Spring 5 adds even less, if anything. There are some new features around some things that are sort of relevant to the JDK 8 upgrade, I guess. So Java 8 has some new language features, right? Lambdas are probably the ones that are most relevant to this. So people have fun doing functional programming these days with Java, and it's much more fluent and much more idiomatic with Java 8. And so we've got in the Spring APIs themselves new APIs for instance, registering beans with a bean factory. So Spring is for those who haven't used it, one of the things that is a dependency management system, and you have a registry of objects called beans, and you register things with the bean registry, the bean factory. There's a functional way of doing that now. And then the next bullet is kind of the biggest one. It's the one that we've spent the most effort on. You might not notice. That's the strange thing. I mean, you will notice today because I'm going to give you some demos, but if you don't want those features, there's no reason for you to use them. But if you do want them, they're going to be great because we spent a lot of effort, a lot of time on the reactive side of things. So who in the room has played with reactive programming in any language? JavaScript, Scala, Haskell, a few people. So Spring 5 was our opportunity to introduce some new programming models. So the programming model, the aim for Spring is to have a programming model. We think about that. We think about the APIs that you use when you're consuming those third-party libraries. And so what we like is for you to have a uniform view of them using the language, the programming model, the domain that's provided by us. And so we've sort of given our own interpretation to the reactive side of that, and I'll show you in a minute some demos of that, and you can see what I mean. There is also support for other new stuff. JUnit 5 just came out as well a couple of weeks ago. It isn't really well supported by the IDEs yet, but as soon as it becomes more usable, it will be great, and it will already be supported. JDK 9, we build on JDK 9. We have a dual build, JDK 8, JDK 9, so we know that it works. A little bit of tiny HTTP 2 stuff. Don't ask me too much about it. It's really just a bit of sugar around the slightly ugly, and also temporary, I'm told, support for HTTP 2 in the JDK. And another thing, finally, that we put a lot of effort into, especially one or two of members of the team got really passionate about it, and that's Kotlin. Kotlin is a new language. Anybody tried it? From IntelliJ. So they, decided they didn't have enough work for themselves writing IDEs, and decided they needed to write a language as well. So Kotlin is the result. It is a very nice language. Spring has first-class support for it, even though Kotlin plays very well with Java libraries in general, which is probably why it's one of the reasons it's so successful at the minute. Spring 5 has a lot of additional features that are specifically targeted to the Kotlin users, and we package Kotlin features inside the jar files, so you don't have to download anything separate. So actually one of the side effects of that, if you like, is that everywhere in Spring now we have @not_null all over the place. So lots of places where assertions can be made where you could have made a mistake injecting null into something and it would have been an error. There wasn't anything to protect you from that except at runtime if it happened to fall over and get a null pointer exception. Now we have a lot of basically startup time or compile time exceptions for things where you would have made mistakes before. And that isn't specific to Kotlin, that just is a side effect of Kotlin being more fussy, or maybe more, the people who use it are more fussy about things like that. They want to have immutable objects and values and things like that, and they want to know when state has changed. So that was a side effect. So in order to accommodate all of that reactive stuff, the layer diagram changed a little bit. So we sort of used to treat, Reactor was in there actually in the previous slides, but in the blue layer. And so it was sort of, although it was a library that we created, I think in 2013 was the first release, the new version of Reactor, Reactor 3, is a fundamental building block of the reactive side of Spring. So there's going to be a whole, Spring 5 is just the first. There are going to be additional Spring project features which sit on top of Reactor, using the Reactor APIs and using the Reactor libraries as first-class dependencies. So I put that in the green layer now. Reactor is really part of Spring now, even though it's its own separate project and doesn't depend on Spring. It really does sit at the bottom of that stack, but it's an important building block. Okay, so let's see some code, because we're all engineers, right? Anybody here not an engineer? Not at all. Okay, right, so code. Let's have a look at this reactive stuff. So the first thing to clarify, I suppose, the first thing to explain is the difference between reactive and not reactive. Okay, so not reactive is this kind of thing, imperative. And the key feature here is that you have blocking blocking APIs, basically blocking input-output. So I have here in my code sample, I've got a person repository where I can do find by ID and get back a person, which is very simple. But the key thing is that when that happens, there has to be, a database connection is made, TCP packets go out, TCP packets come back, the whole thing is reassembled, turned into a person, and all of that happens in the main thread. And there's no way to do anything else while that's happening. It's blocked, basically, by the I/O stack in the operating system. And then, so you see things like try, catch with an exception. It's very sort of linear, very straightforward. You can see, you can sort of read the code and execute it in your head. And that's why it's called imperative, because it's imperative. You do this, and then you do that, and then you do the following. And so the person repository has this kind of structure. It has things like find by ID, returning a person, find all, returning a list of persons. And all of these methods implicitly block. They may not explicitly. It depends on the implementation, but pretty much they do. Otherwise, they wouldn't be written like that. Certainly, if there's a database or any kind of input-output network stack or file access involved, they block. And then if you look at the same thing in a more functional style, where you have the opportunity now to be non-blocking, the opportunity, I say, not the right, but the opportunity to be non-blocking, you actually have to take steps to do both, it would look a bit different. So the person repository interface has the same method names with the same signatures, except the return types are different. So these things, instead of returning a person, I return mono of person, and mono is part of the reactor library. If you haven't seen reactor before, reactor 3 that is, reactor 2 didn't have it and it was called something else. In fact, in reactor 2 I think it was called stream. So if you've seen Java 8 streams, it's a bit like that, except mono, there's only one of them. All right, so this is saying I'm going to give you a person at some time in the future. It's also a little bit like a future from the Java util concurrent package, but not. Okay. I may not have time to go into the details. The essential details are between the difference between streams. So mono is a bit like a future. Flux is a bit like a stream. You can think of it as either a finite or an infinite set of persons that arrive at some point in the future, and you don't know when they're going to come. The key. Why is, yeah, sure, right. So actually what I'm going to do is open up an IDE in a minute so I can look at the APIs for you and show you explicitly. But broadly speaking, the difference is these mono and flux are from the reactive streams API, and they specifically have features for controlling the flow of the objects through the streams. So whereas a Java 8 stream, for instance, you can do, a stream can take an operator like map, and then you map the objects to a different type, transform them. So Flux has that feature. As a user of a Flux, it feels a lot like a stream. It's the consumer that's different. So the consumer can control the flow of the items, the persons in this case, out of the Flux. He can ask for one at a time. He can ask for as many as you can give me. He can ask for, give me one every 2 seconds. That kind of control is available with the Flux, with the reactive streams, I should say. And Flux is an implementation of reactive streams publisher. Probably you could use publisher there as well. Reactive streams doesn't distinguish between mono and Flux. That's one of the reasons that we have a separate library, a separate API in reactive streams in Reactor. So mono and Flux are both publishers. They publish persons. One of them only publishes one. It's guaranteed to only publish one. Okay, so then the code with the try-catch in the previous example, so person repository find by ID, and then that responds with a mono of person, and then I can do things like map it to a handler, do something with it. That was, do you remember in the previous slide, I didn't point that out. Whoops, page up. In the previous slide, I had a handle method where I handled the person. Here I'm going to, it would have been actually probably better in that case to return handle of P. That was a bit more expressive, I think, of what this does. So I map to the handler. The handler returns something. It's actually a person is what it's going to return, so it's transforming it. This may be, you know, an oversimplified example. And then instead of try catch, I've got do on error on the flux, on the mono, the publisher. And I don't know if you've played with the reactive streams or if you've played with Java 8 streams, you'll kind of recognize the pattern here. When I write this code, it's not like the imperative version where as I step through the code, those things are happening. This is different. This is more like this is more declarative. It's an execution plan. It says, when somebody eventually subscribes to you, you're a publisher, you're going to publish a person. When somebody wants to see that person, these are the things you've got to do with it. It's a plan of execution more than anything. So that's kind of a different way of thinking about things, and that's why they call it functional, because it's sort of declarative. It happens also to be a good model if you want to do non-blocking I/O. So non-blocking doesn't mean functional, or vice versa. But if you are going to do non-blocking, you often end up with a functional style of programming. So why is anybody going to care about this? That's really, I suppose, the question. And the answer will be to do with the kind of problems that you're solving. So if you have like maybe a gateway or something like that, something with a lot of traffic that doesn't do a lot of work, then it's a good candidate for needing this kind of non-blocking functional programming implementation. It's neutral to latency. So the key thing is that you push what would have been a thread pool, essentially. So imagine the difference between a blocking and a non-blocking web server. The blocking web server, like your Tomcat that you use today, for instance, has a thread pool. If a connection comes in, a thread is assigned to the connection, and it does the work, returns the response, and then the thread is sent back to the pool for the next one. Reactive web servers don't have thread pools. You can add them, like if you wanted to control something specially, but naturally they don't have thread pools. There's a mechanical sympathy, they call it, mechanical sympathy between the number of cores processing in your physical machine to the number of threads that can handle work. So if you've got a 4-core machine, it can handle 4 concurrent things, and each of those 4 could be, 1,000 HTTP connections instead of being 1 thread and 1 HTTP connection. So the result is, for certain use cases, it will be less prone to nasty resource issues to do with running out of threads, running out of memory, that sort of thing. It will handle, it will scale better, and it will be less troublesome with latency and I/O blocking. So with the I/O, all you've done is you've pushed it down the stack, right? You've pushed it down from the JVM down into some other layer. The operating system has to handle it now. But the network stack and the file system that you have in your computer already does that quite well. So what you're doing is you're saying, I don't want to bother with thread pools anymore to do stuff that needs to be in the background. I'm going to give it to you, operating system. Go and handle that yourself. So it's not like you can't push these problems away forever. They're going to go somewhere else, but you've taken it out of your hands, basically. And that might be a good thing, or it might be a bad thing, okay? I've seen a lot of people who've taken their existing blocking application with a database in the back end and just slap on some reactive stuff and found that it was worse, or at least not any better than it was before in terms of scalability and performance. Not every problem will be solved using this kind of feature, but some will. Like I said, it's often going to be high traffic, low latency. Those are the features that you'll be looking for, where there is a non-blocking. The key thing is with this repository, for instance, you need to have non-blocking I/O behind it, otherwise it's pointless. So you can't, for instance, use JDBC or JPA, relational databases, at all at the minute. They just aren't, they don't have non-blocking libraries. There is, so you could have a repository at the minute built on Mongo has a non-blocking driver, React, probably. Redis has a non-blocking driver. So there are a few back-end stores that you could use that would support this kind of model, but it's probably better to think of it as more of a gateway where the back-end is naturally non-blocking. Okay, so you've probably all, anybody who's used Spring, sorry for the people who haven't, probably has done this before. Spring MVC, if you want to do HTTP, you say, here's a get, HTTP get on this path, and when that request comes in, I'm going to take the ID and I'm going to turn it into a user using my repository. So I'll just fire up a quick demo that does something like that. I don't think I can move any further back to stop that from happening. So I can't change the font size there, but I can change it in the code. Can anybody not see that? Is that okay? So I'm going to start a new Spring project from this wonderful website, which if you haven't seen is a nice place to get started. It's a website with a UI. It's also a web service that I can use in my IDE. All the IDEs support this. So I'm going to use Spring Boot 2.0 M4, and I'm going to use just plain old Spring Web MVC, the old stuff that everybody knows. And I'm just going to write a quick web app. So here's a Spring Boot application. It's also going to be a REST controller. Whoops. I don't know what it is about Eclipse. It really doesn't want me to do this today. Get mapping to the home page. So I'm going to say public string home return hello. Oops. This is typical hello world. Hello Dublin. All right. Then if I run that, run as Spring Boot application, Java application, doesn't matter. Then there it goes. So Tomcat started on port 8080. So if I go in my browser to port 8080, I see hello Dublin. Okay, so that's old style, bog standard Spring MVC. And if you replace that with your repository call and return the string if you prefer it. So that's Spring MVC. That's what we've all been using, and what has been available since, well, roughly speaking, since Spring 2.5. This is what it looks like for a reactive application. Spot the difference. Not very much difference, right? So we're using actually the same annotations. That one might be different. I wouldn't swear that's exactly the same, but it looks the same. The only difference is, oops, the repository signature changed because now I've got a reactive repository, so I need to return mono of user instead of user from my web endpoint. So let me just prove that that works. Okay, so instead of editing the POM, I'm going to use this little feature here. I wonder if it will let me. Spring, there we go, Spring. So back to the list I had before. So instead of web, I'm going to go reactive web. Stop the old one. That would have changed a dependency essentially. So instead of Spring Web, I've got Spring Web Flux. Spring Boot starter web flux. I just changed one dependency basically there. And then I'm not going to change the app at all, actually. I could not change the app. What I'll do is I'll do what I did on the slide, which is instead of returning string, I'll return mono of string. So that just has to be, I'm going to fake my repository here using mono just the string that I give it. That's just a quick way to produce a publisher from a value. And that should do it, actually. So let's see, run as Java application. And if you look at the logs, instead of Tomcat, it's Netty. Tomcat works as well, but we decided to use Netty as the default. If you use Tomcat with this kind of programming model, what you're getting is servlet 3.1 async processing. So it's still thread-bound. But if you use Netty, you're getting full reactive non-blocking all the way down to the operating system. OK, so it's running, which means here I can just refresh. Maybe if you don't believe that that's actually running, I should curl it localhost. Says hello Dublin. OK, so more or less the same code. Just change the signature a bit. And of course now I can. This is really cool, right? This is almost the same programming model, going from old style Spring MVC to reactive, and we've just helped you a little bit, made it as comfortable as possible for all Spring users to use these new cool things. We can also, I'll throw in a bonus here. I'll show you something really cool. You can, here's a Spring Boot feature, auto-configure web test client. So what that's going to do is I'm going to write a test, because we all like tests, don't we? If you're from Pivotal, you really like tests. So I'm going to say web test client. That will be auto-wired. And so that's actually in Spring Test, the sort of low-level testing library from the Spring framework. And it's a bit like any HTTP client, but so it has things like I can do get of a URI, oops, and I can get the body. How do I do that? Exchange, probably. And then expect the body to be of type string and equal to hello Dublin. Isn't that neat? Let's just check that it works. So, oh, you didn't see me do that. I'll do it here. Run as JUnit test. This is JUnit 4. It would work with JUnit 5 as well if I change the annotations at the top here. OK, so what does that do? What does that do? The URI there didn't have a http:/localhost 8080 in it, right? So that's what the cool thing that this does. It sets up the web test client and also prepares it with the right host and everything. In fact, it's even cooler than that in this case, because Spring Boot Test by default has a web environment of none. It didn't even have an HTTP stack running in that test. Okay, so it works with the default, which is none. It also works with web environment random. So it'll create a random port, pull up the whole Netty stack, serve the endpoint on HTTP, and then the same test with the same web test client will still pass. Let me just check that that works. Yay. What I would like to do actually is show you the console. There we go. There's the console from the test. So that one started Netty. And if I did web environment none, then no, that one now doesn't work for some reason. This is why I always practice my demos. There we go. That is the same thing. Don't know why none didn't work, but that is none because there's no Netty there. All right. it's just an application context with no HTTP stack in it. So that's cool, right? If anybody's writing tests for Spring for web applications with MVC, you can do this kind of full stack integration test with REST template. You could also do it with web test client. But you have to use mock MVC if you want to do it without the full stack. You have to use a separate parallel HTTP client, and this is the same client. So web test client can handle local non-HTTP client tests of the endpoints as well as full stack HTTP. So that's neat. Let's see what I've got in the slides. So that was transitioning from MVC to WebFlux. The next stage actually is another feature of this reactive stack. So let me just, and that's the reason I've got a test actually, is because I want to refactor this. So it's no longer a REST controller, but it has a bean. This is a more functional style of programming. So I'm going to say public function handler function. Is it handler function? I might have to give up. There it is. Handler function. That's the one. Handler function roots, or is it root function? Root function. I nearly got called out there, didn't I? Yes, router function. Router function. So I'm defining roots. Instead of using @get mapping, I'm going to say return root. Return a root. So there's a helper method for a get of the home page, and the handler function is going to be from a request to a response, and so I'm going to use OK. I'm saying that it's OK to have a response, and the body is going to be a mono of the same thing that I'm doing down there, actually, so let me just copy it. Oops. So the body is going to be the hello Dublin, and it's of type string. I think that's all I need. I'm going to cheat and look at the slide in a minute if that didn't work. So basically what I've done is I've turned the @get mapping into a more functional version of the same thing. So I'm saying, here's the path. If you see that path, use this handler. And so you can add other types of predicates there. So I could do get using different predicates to test headers, is it authenticated, that kind of thing. But the basic idea is that that test should now still pass, right? Still says hello Dublin. And it's green. Okay, so I got that right. So that's an alternative programming model using the Spring reactive but not WebFlux. So WebFlux is the term we use for this annotation-based programming model, which is like MVC, which is reflective. And this is more functional, declarative, less reflective, because this is the handler that will be called. You don't have to reflect on a method and call it reflectively to get the handler called. Some people will prefer this. It's a matter of taste. Some people will prefer this, and this looks to me like something called Ratpack. Has anybody ever used Ratpack? It's a little bit like the same programming model that they use there. So people who prefer it will use that. Well, I mean, I use the word reflection, right, which is a little bit loaded. So yeah, technically speaking, there is more reflection here. So it will be, a couple of microseconds per request slower. It's essentially the same at runtime, frankly. It won't make much difference. It's more like, I don't know. Yeah, I don't know. It is really just taste. For me, I don't think I don't expect to see many apps written like this, explicitly like this. I expect to see, a method reference there. So Instead of lambdas, you'll see a method reference to somewhere else, and that's a much nicer style, actually. And you can line them up. So I can do, I could extract that into a method. No, I'm not going to try and make Eclipse do it. But then you can add other routes as well. So you can say and another route, and another route, and another route, and another route. So you can have all of your kind of routing table in one place. Some people will like that, I predict. I showed you the test client. I didn't show you the sort of non-test counterpart of that. So there's a new HTTP client in Spring 5, which is actually, although it's reactive, you can use it anywhere. So a sort of general purpose web client. If you like the functional programming style, if you like the fluent programming model, you can just use it instead of REST template. So it has things like, fluent programming model, client.get.uri, a bit like the test version that I showed you. .retrieve is your way to just grab the response. And here I'm turning the body into a mono for somebody to analyze later, right? So the important thing to realize when you see that, when you see mono as the return type, you know that nobody's actually going to call HTTPS API github.com. Nothing's going to happen until they get downstream, they get that result, and then they subscribe to it. So somebody has to subscribe to the publisher before any of this code gets executed. That's kind of the cool thing and the thing to remember about it. There's the test client. I showed you that already. So basically, if you just @auto configure web test client, you get one of those for free with a Spring Boot test. Here's a useful thing to know. So one of the features of web client is that, well, one of the features of the reactive functional programming style is that you can do things like combining results of future results in a neat way. So here's an example where I do get me a Twitter user using a web client, which is mono of Twitter user, and then do the same thing and get me a GitHub user, and then you do GitHub user and Twitter user, and then you combine them together into some combined object that only appears when both of those are available. In fact, it doesn't appear until the receiver of this thing subscribes to it. And then, so when the subscription comes along, somebody grabs an item out of that mono. 2 requests are going to go out, and, whenever the stack can handle it, whenever the I/O stack is available. It's not threads. It's just, when the network stack can handle it, and the responses come back when they come back, and then they're folded together and turned into an app user. So it's a nice sort of expressive API for combining future results. So I tried to explain a little bit of this already. What it comes down to is instead of you having control over thread pools and having to pick a thread pool size, if you had a scalability problem with a Tomcat app, you go and find all the thread pools and you change, you increase double the number of threads in every thread pool, increase the amount of memory you're using, cross your fingers, hope that it works, and you have things that you can change in non-reactive applications that will make your app scalable and stable, but it's always within a certain range of parameters, whereas the reactive stack, because it's non-blocking, adapts better to different levels of traffic, for instance, and you don't have to tweak the thread pools depending on how much traffic you've got. On the other hand, the servlet stack is not going away. The standard's still there. The servers are still there, still being worked on. It's much simpler, frankly. And if you don't have a high traffic, hugely non-blocking problem, then you might as well stick with the old stack. It's not going to go anywhere. We're certainly not going to stop supporting it just because there's this new thing that's come along for some problems. Okay, so here's a table of where we are. Reactor Just had a Bismuth release that was there to support the Spring Framework 5.0, which was today. So building on top of that stuff now, you've got other things in the pipe. So you've got Spring Data K is being worked on with reactive drivers for reactive repositories, essentially. So you can have reactive repositories as long as the driver in the back end is reactive. So they've got them at the minute for, like I said, I think Mongo, Redis, one or two others. I can't remember the exact details. Spring Security is probably the most popular part of the Spring world, apart from the framework at the low level there in that bottom green box, and most people using it. Spring Security 4 is, on the web side, is totally tied to the servlet API. It's also completely reliant on thread local, so it's thread-based, thread-bound, and the reactive programming models don't know about threads. They don't guarantee that the code that you write is not executing at the point where you write it. Remember, it's executing downstream when somebody subscribes to the publisher. So they can do that in any thread they want. There's no reason that they would do it in the same thread that you declared the execution plan. So thread local is no good anymore. They need a different way to capture the security information and propagate it down to the lower levels of the call stack. So the first pieces of that are in place. They haven't released 5.0 yet. They have a couple of milestones. They're coming up to a release candidate sometime towards the end of this year. Spring integration is a little bit closer. They're almost ready for a release candidate, I believe, so they've got new reactive programming models inside there as well, and other stuff. Okay, all building on this reactor project. And I mean, I suppose the good news is that if you don't care about Reactor, you probably won't notice. But if you do, then there's this deep stack of stuff that you can now consume in a very convenient and consistent way. The Spring Boot release, which is matching Spring Framework 5 and Reactor, is 2.0. We thought we could do it in 2017. I'm not so sure now. I think the official date has slipped out to January. So after Christmas, I expect Spring Boot 2. And Spring Cloud will have a Finchley release. So F is for Finchley. The current release is Dalston, so there's an edgeware in between. What we aim to do is support, I'll show you a slide of that in a minute. We aim to support new features on Spring Boot 1.5 and then quickly switch over to Spring Boot 2 as soon as we can with Finchley without necessarily adding a lot of features, but with just supporting all the new libraries. So here's the Spring Cloud slide. Dalston's where we are now. That was released earlier this year on Spring Boot 1.5. Edgeware, we are hoping, will be out in Q4, also on Spring Boot 1.5. And we are expecting that Finchley will come relatively quickly after Spring Boot 2 because we're trying to track all the changes in Spring Boot 2, but it is very difficult. Anybody who's building libraries on top of Spring Boot, it's difficult. Spring Boot 2 is a big change, much bigger than the Spring Framework 5. Anybody who's not building libraries on Spring Boot probably doesn't care, right? I mean, because the code that I wrote here tonight, it wouldn't care if it was Spring Boot 2 or Spring Boot 1.5, except for the reactive bits. Okay, so your old style apps will probably still work, but any of the new stuff you need Spring Boot 2 for. So the reason I've got two slides here is because there's a new thing called Spring Cloud Function, which I haven't got time to talk about tonight, but we might put it in Finchley or we might put it in Edgeware. We haven't really decided yet. We have a version that works with Spring 1.5, so we still have that option. That's kind of it. So before I leave, everybody do this when they get home, right? Type in Google Spring 1 Platform 2017 and go to this website. So this is our annual big user conference, basically. If you want to learn about any of this stuff in more detail, all the cool things that are happening in Spring across all the projects, Spring 1 Platform is in San Francisco in December. And that's the best place to learn about it. The other links there are all basically project links. I showed you the initializer. the Spring Boot project, Spring Cloud, Reactor has its own website. Reactive types, so there's a nice blog there, Understanding Reactive Types. If you type that into Google, you'll find this blog by Sebastian Deleuze, who's one of us, explaining the difference between streams and fluxes and the questions that I was being asked earlier on. And then reactive streams is the standard API that Reactor sits on top of, so the publish and subscribe models, which have now actually been adopted in JDK 9 in a sort of slightly weak form. And that's it. That's all I had. So we've definitely got time for a couple of questions. I expect there is another slice of pizza if anybody wants it, and maybe a beer. But we can do a couple of quick questions, and then we can just chat if you like. It's up to you. Anybody got any questions they want to speak into the microphone for?
Let's just give Dave a big round of applause for his
Oh, no, please. I work for beer.
So are there any questions?
Thank you. Have you considered removing the mono or flux part from the signature of the controllers to make the code more readable and less Javish?
Well, you can still do that, but if you do, then what you're doing is you're saying that you are going to block inside that. Yeah. You would have to block to return it. Yeah, yeah. So you're forcing the code inside to do something it didn't want to do. I mean, so yes, the answer is we have thought about that quite a lot, but the reason that WebFlux and MVC are actually parallel universes is that they don't mix. You actually can't use one to express the intent of the other, unfortunately. If you start playing with it, you'll realize why, I think. There are, yeah, and I mean, there might be some clever things you could do. Although I can't offhand think what they would be, to, I don't know, sort of, yeah, yeah, I don't know what the point would be somehow. Is it like, yeah, I mean, he's talking about making the code read better, and I kind of get that, but the problem is that it doesn't actually, because when you understand what these publishers do, you want that programming model because you want to be able to put predicates on them, filter them, and transform them, and you want to operate on them and tell the downstream consumer how to behave. It's much more powerful and much more flexible than just returning a person actually. And that's, if you need that, that's what you want. If you don't need it, then just stick to MVC. Is there another question?
Yeah, I just wanted to ask that what's informed the decision to create the reactive side of Spring?
What?
What informed the decisions to...
What informed the decision?
To create the reactive side? Was it because of, in Java 8, there was some kind of functional programming added to Java 8?
Yeah, that gives us a vehicle. So Java 8 gives us a way to express the ideas. You could have done this in Java 7. You just would have had a lot more, less lambdas and more anonymous classes. So for instance, there's a reactive streams implementation called RxJava 2, which runs on Android and therefore doesn't need Java 8, and it's all the same programming model. So you don't need Java 8 for that, but it's a nice way to express the ideas. Now what's driving it is this, the expressiveness of the programming model. So the functional side of it is one thing. Some people like that, right? The other thing is the non-blocking. And the non-blocking is really about scalability and saving resources. So these particular workloads that are high traffic or variable traffic and low latency. They're expensive to run in a data center. They use a lot of joules, right? A lot of power is used up by the memory and the CPU and the resources that have to be alive when those web servers are accepting load, and even when they're not, actually, frankly. So that's the thing. And so you can have a essentially more efficient, cheaper data center if you're non-blocking. That's what's driving it, fundamentally. That and the fact that people like functional programming. It's two things. We realized we had to do it early 2014, I would say. So about 2.5 years ago, we started work on the reactor pieces and the early prototypes of the WebFlux, the programming model for the web stack. So it's been, a good journey, more than 3 years' work for quite a big team. So yeah, and now that's just the Spring, the bottom layer. Now everything has to sort of slot in on top of it. So we're working hard on that to get that out at the end of the year, beginning of next year.
Any other question?
One here.
RxJava has like schedulers for sort of mixing in blocking and non-blocking code. Is there any plan to add something similar?
It's it's in the RxJava is very similar. It even has the same people working on the teams. So for instance, you've got subscribe on a scheduler and publish on, and so there are ways to introduce threads if you need to. So that it's important because not everybody is in one camp or the other. There are some sort of mixed models. So for instance, in Spring Boot 2, are you familiar with Spring Boot? So we have these, what we call actuator endpoints, which are sort of management endpoints, which are either web or JMX endpoints for looking at, stuff going on in the application, business intelligence basically, and operational intelligence. So they were previously in Spring Boot 1, they are blocking MVC endpoints. In Spring Boot 2, some of them still block, so you can't change that, but we want them to be at least capable of being non-blocking. So we have a non-blocking API for them, and you can mark them as, it's sort of relevant to your question actually, you can mark them as, this is going to block, so please put it on a background thread when you call it, because you know that it's going to block. So you can work around some programming models where it's sort of what I had in mind when I was trying to answer you. That there might be hints that you can give the consumer of your code that says, I know I'm going to block, so just put me on a background thread. It's not the best solution, right? That's not the way to do non-blocking reactive programming. If you have a non-blocking I/O stack, you should use it. But if you know it's going to block and you have a mixed I/O stack and you know some bits are going to block and some bits are not, then you have to use those tricks. You have to be able to control the threads. It's actually really cool. So in Reactor, they have a scheduler implementation which is elastic. I think RxJava's got exactly the same feature because the same people implemented it. So it grows, the thread pool grows on load and then shrinks again when there's less load. It's actually kind of cool. There was another couple of questions up there.
My question is, what do you think will be the next step for a Spring, like big step like WebFlux was for just Spring 5?
It's hard to predict the future, right? Well, we knew about that 3 years ago. I'm not sure if we know what the next thing is. Spring 4, I'm trying to remember when Spring 4 came out. Probably was 4 years ago. I don't know, is the short answer. Who knows? Who knows what will come in the JVM? I'm quite interested in the fact that some people think that Spring is slow. That might just be education, and there might be nothing we can do. But I think the JVM would benefit a lot from being able to, at least for people to perceive it to be not slow. and not resource inefficient. And it is a bit resource inefficient if you're doing blocking I/O, for instance, so because you're handling it all in the JVM where you could have pushed it down to the operating system. So maybe, I don't know, maybe somebody will come up with some neat things that will help with resource utilization and startup time and things like that. I've done a lot of measurements of that. The JVM is quite highly optimized for running extremely fast over a long period. It doesn't really care so much about the startup time, which is what we notice when we're developing. So there's certainly some room for improvement and optimization. I don't know if Spring will be able to help with that or not, but we can certainly push the measurements in the right direction.
Thanks.
You said that Spring Cloud is focused on distributed systems like Netflix. Is the Spring Cloud using all this non-blocking stuff and reactive?
Well, I mean, that's part of the reason that we have to have a Finchley release so that we can move to the new stack, mostly driven by Spring Boot. So some parts of the Netflix stack are reactive, but it's all the old model. It's all thread pools and RX Java 1, basically. So yeah, I mean, there are new features coming into Spring Cloud which are driven by the reactive stack. None of them come from Netflix at the minute. All the reactive stuff that they've done, they've kept in-house, and they haven't open sourced it. Interestingly, I mean, they're very, very motivated by this idea of saving money in the data center, right? They spend a lot of money on thread pools, basically. They're quite motivated to reduce the amount of money they spend on Tomcat and use more Netty and use more non-blocking I/O. But they haven't open sourced most of that. So we're doing some of that on our own in Spring Cloud Finchley. There's a new project called Spring Cloud Gateway, for instance, which is built on the Spring 5 reactive stack for doing proxy patterns, basically, API gateways, which kind of replaces the Zool stack from Netflix, which they have a reactive version of, but they haven't published it. It's in-house.
Anyone else? Let's give another thank to Dave.